Hi, this is Mr. Buford. We're going to go ahead and take some notes on systems of linear equations. I want you to stop the video and copy down this data here from the notes section. And when you come back, we'll go ahead and talk about it. So go ahead and stop the video and copy these down. Okay. A system of equation is simply two or more equations with the same variable. Suppose I had x plus y is equal to 5 and x minus y is equal to 1. That would be a system of equations. I have the same variables x and y, and there's two of them. If I only had one, it wouldn't be a system, it'd just be one singular equation. So a system has to have two or more equations and the same variables in each equation. We're looking to solve them. We're going to solve them two ways. We're going to focus on graphically today. We're going to focus on finding the x and y coordinate where the two lines intersect. So we're going to graph the equations on planes, and we are going to see where they intersect. If we were solving them algebraically, we'd be looking for that coordinate point that would make both sides of the equation true. There are three possible outcomes for types of solutions. There's when the lines intersect, intersecting mean where they cross, and that coordinate point that's created there by the two intersecting lines is the solution that we're looking for. We can also have the situation where lines are parallel. They do not cross, and therefore there are no coordinate points that make them both true, so I have simply no solutions. Or I could have two lines that lay on top of each. One lays on top of the other. As you can see here, this line, the solid line, lays on top of the dashed line. That means every point on those two lines are solutions, and that means I have an infinite number of solutions. To solve them, we are going to simply rewrite the equations if they're in a different form, but rewrite the equations so they're in slope-intercept form. And I made a how-to video that you got, or you can look up, on writing in slope-intercept form. And then after you get them in slope-intercept form, you're going to simply graph the line by starting at the y-intercept and following the slope to the second point. After you find where the two lines cross or don't cross or they lay on top of each other, you can identify the solution by either the single one solution coordinate point, no solutions for parallel, or infinite solutions for the same line. Let's go ahead and stop the video another time after we get ready to graph this. I want you to go ahead and graph this, stop the video, graph this, and then watch me graph it when I'm done. Okay, we're going to go ahead and graph this starting at the first one. This is the first equation, y equals x minus 8. The y-intercept is negative 8. The slope is positive 1. So we're going to start at negative 8, which is below the x-axis, at negative 8, which is right there. And it has a slope of positive 1. That means I'm going to have a slope with a rise of positive 1 and a run of positive 1. Because every whole number has a 1 on the bottom, because you have to have a rise and a run. So I'm going to go up 1, positive 1, and to the right 1. And I can just continue that pattern quite a ways. Doesn't matter how many times I do it. The more the better, because it gives us the chance to get a very straight line. Take your straight edge. I use a protractor because they're small and straight on one end. And remember, we're going to go through the graph, putting our arrows on both ends of the line. Now let's go ahead and graph the second line. It has a y-intercept of positive 1, which is right here. And I'm going to follow the slope on this one. On this one, the second graph is going to have a slope of positive 2. Let me focus this back up again. It's going to have a slope of negative 2, a negative 2. And it's going to have a run of positive 1. Now that's graphing forwards. I could also change the signs, make this a positive 2, and change the bottom to negative 1. So I can graph backwards and forwards on this one. If I graph forwards, because I want to graph towards the other line, I'm going to go down. I'm going to go graph a negative 2, negative 1, negative 2, starting there. Negative 1, negative 2, positive 1. Negative 2, positive 1. Negative 2, positive 1. You notice that I'm crossing right there at that point. Just continue the pattern, and you'll see that it graphs at that point. I can draw my line, line up my dots very carefully, go through the graph, arrows at both ends. What I'm looking for is where the two lines cross, and you'll see that it forms a coordinate point at that position. And that coordinate point is at positive 3 for x. See this 3 right here. And that's positive 3 for the x and negative 5 for the y. So at positive 3, negative 5, those two equations have solutions for both sides. If I plugged in the negative 5 on the left and the positive 3 on the right, negative 5 is equal to 3 minus 8. So negative 5 equals 3 minus 8, I would have negative 5 equals negative 5 because 3 minus 8 is negative 5. So you would see that both sides of this equation are the exact same. Even if I plug it into the second equation, I get negative 5 on the left. Negative 2 times that 3 is negative 6 plus 1. Negative 6 plus 1 is also negative 5, so I get negative 5 on both sides. If you want to see that, just ask for that in class. Let's go ahead and graph this one. I'm going to graph it after you do, so go ahead and stop the video, graph this one, and then come back to see if you did it correctly. Okay, starting here at positive 9. Positive 9 is at the top, and then we're going to have a slope of positive 1 over positive 2, positive 1/2. So I've got positive 1 over positive 2. Now notice I cannot go any further up, so I have to go graph backwards. So I can change the signs to negative 1 over negative 2, which means I'm going to graph down and to the left, down and to the left, down and to the left, down and to the left. And I can just continue that pattern, and you see that I draw a straight line with my dots. Going to connect it very carefully, because remember, neatness matters. Always, always. Always want to do our best work. And then we're going to have that line, arrows at both ends, remember. The second line starts at positive 6. Here's my positive 6, and it has a slope of negative 1. Now, a slope of negative 1 is going to tilt downwards. So I'm going to graph towards that other line. So instead of graphing down and to the right, I'm going to graph up and to the left. So I'm going to graph my slope right now as negative 1 over positive 1, or positive 1 over negative 1. I'm going to go up and to the left instead of down and to the right. So up 1 over 1, up 1 over 1. And you see that when I do that, I cross right here. And then I can draw my line very neatly. And I'll have, through the graph, arrows at both ends. I'll have that coordinate point. Now that coordinate point is at negative 2. If I come over negative 2, so that's the line, negative 2, positive 8. So it's negative 2, positive 8 is my coordinate points, the solution for those two equations. And if you plug them in, you'll see that both sides of the equation are equal. We can try that in class if you need to. Now I'd like to point out something on the back of the work. One second. On the back of the work of the sheet that you're going to be working on, you'll see there's a couple of equations that have here. We see that this one says here that it's y equals negative 7. Remember, y equals equations, that's an equation that would normally be y is equal to 0x minus 7 with a slope of things. So this is a horizontal line. It has no slope. So y equals equations are horizontal, which means it's a flat line, left or right, and it's going to go through negative 7, which is down here, 10, 9, 8, 7, which is right here. It's going to go through that. Okay, and you would simply have to graph the other line. Just want to point these out to you. These are some things that you may not remember, and if you don't, I want to bring them to your attention every time. That horizontal lines have y equals a number, either positive or negative. If it's y equals 0, then it's the horizontal line across the x-axis. Now this one down here at the bottom, number 8, you'll see that number 8 has an x equals negative 2. X equals negative 2 signifies that it's a vertical line. This is a vertical line through negative 2. So if I was going to draw this, I would go over here to negative 2, which is right there on this. And I'm going to draw a vertical line following the lattice there. Arrows at both ends. And that's going to be the line for that one. You would simply have to put this one in slope-intercept form and find out where it crosses there. And you're going to put this one in slope-intercept form and find out where it crosses here. So that helps you with these. Now, the other three equations, there's 1, 2, 3, and 4. The other 4 equations, 2 of them are going to be single solutions. One of them is going to be parallel, and one of them is going to be the same solution. Go ahead and figure out which ones they are. There's 2 of these that are going to be again, a single solution. One is going to be one of these two, or these two are going to be a parallel line or a same line. So you have those three solutions in the back. So go ahead and finish up these notes. Stop the video, finish these up, and then I'll post the answers to the back. Okay, so the answers to the back are this. Let's take a look at the answers to the back. The answers to the back look like this. So if you did them, and you'll see that number 3, we got this one. It crosses down here. This one, it's at -5, -7. See if you got that. We finished this up. This one here, I just drew the horizontal line for you. This answer was 6, -7. This answer here is one of the single solutions. It's -5, +4. Go ahead and check that out. You had to put both of those in slope-intercept equations. Here's the one that's going to be the same equation. When you take this is slope-intercept form and standard form. When I convert that to standard form, I get the same equation. Notice that. And that means that line is going to be on top of itself. So I drew a second set of arrows out here to the end. And that gives us an infinite number of solutions, because every coordinate point that falls on that line falls on the other one, and means they are the same line, and every set of x and y works. These two are parallel lines. Parallel lines have a distinctive thing you could tell. They have the same slope. This one has a slope of +1. This one has a slope of +1. But they have y-intercepts that are different. This has a y-intercept of +5. This one has a y-intercept of -2. So they're parallel. That means they have the same slope, different y-intercepts, and I have 0 solutions. Here was my vertical line that went through x equals -2. When I the other one slope, I get the solution of -2, 6. All right, go ahead and try your homework. Stop this. Come back and review this video as many times as you need to see if you can need any help in class, and I'll be glad to help you.